Okay, we start 13.2, size 13.2, and we have seen first principle. And in the starting, we have the questions on the derivative. Find the derivative by first principle. The question number 1: find the derivative of x square minus 2 at x is equal to 10. Okay, so d by dx. Now we will use d by dx. D by dx of, you have to find x square minus 2. But we are using first order, first principle, derivative by first principle. So that is fx plus h. That means x plus h whole square minus 2 minus fx x square minus 2 divided by h. So limit h tending to 0, h tending to 0, whole square. You can open the square, x square plus 2x h plus h square minus 2. Open the second bracket, minus x square minus minus plus 2 whole divided by h. This minus and plus cancelled. And minus x square plus x square also cancelled. So limit h tending to 0. H is common. H common. So 2x plus h is left divided by h. So h and h cancelled out. Now you can put the value of h. So this will become 2x plus 0. So the answer is 2x. Okay.
Yes.
So like this in the starting, we have to do by first derivative. It's very easy type of question in our textbook. We'll take question number 4, second. Question number 4, second part. Second part is fx is equal to given as x. Question number 4, second part is fx is equal to x minus 1 into x minus 1 into x minus 2. X minus 1 into x minus 2. In this one, better to simplify first and then you can differentiate. X into x square, x into minus 2, minus 2x, minus 1 into x, minus x, minus minus plus 2. So your answer is x square minus 3x plus 2. Okay. Now find first derivative by first principle. D by dx of fx. That can be written as f dash x. Same thing. F dash x is equal to limit h tending to 0, fx plus h. X is replaced by h, so x plus h whole square minus 3 into x plus h plus 2. This is fx plus h, and minus fx. Minus fx is x square minus 3x plus 2. Okay, divided by whole divided by h. So limit h tending to 0, x plus h whole square, x square plus 2xh a plus b whole square, a square plus b square plus 2ab. Minus 3 multiply inside minus 3x. This minus will multiply with h, minus 3h and plus 2 as it is. Minus multiply inside minus x square minus minus plus 3x minus 2, and this whole term is divided by h. Plus 3x minus 3x cancelled. Then x square is cancelled with minus x square. And what else is cancelling? Yes, plus 2. Plus 2 is cancelled with minus 2. Okay. So in the numerator, we will have only 2xh plus h square minus 3h divided by h. Okay. 1, 2, 3 terms left. Okay, now take out common h. So limit h tending to 0, h is common. So 2x plus h minus 3 will be left divided by h, and h cancel. Substitute the value of h. So 2x plus 0 minus 3. So answer is 2x minus 3. Now we will take cos x. Find the derivative by first principle. We are doing what? Find the derivative of. This is question number 10. Number 10, 13.2. Question number 10. Find the derivative of cos x. Cos x by first principle. D by dx. Just this is like that we have done with sin x. Cos x, d by dx of cos x will be equal to limit h tending to 0 cos x plus h minus cos x divided by h. Now here you have to use the formula cos c minus cos d. So cos c minus cos d means sin will come. You can write minus in the starting. Minus 2 sin c plus d by 2 and sin c minus d by 2. Okay. When you absorb this minus here, so this will become, if you will not write minus here, what will be the change in the formula? This minus will go with second sign, c minus d. So minus can go inside. So this will become sin d minus c. So either you remember with minus or d minus c. It is up to you. You can use any one. Now, yes, we can put h tending to 0. Better to use this one formula minus. So minus 2 sine c plus, what is c here? You will put c and d. C is x plus h, c x plus h plus x by 2. C plus d by 2 sine c minus d by 2. Sine c minus d by 2. And this whole is divided by h. And this minus 2 can be taken out. It is constant. It has nothing to do with the limits. Can be taken out from the limit. Now x plus x sine 2x plus h by 2. And here minus minus will cancel. Sine h by sine h by sine h by 2. But this minus 2, not minus, minus you can leave it here. This 2 can be written as 1 by 2. So we can write this 2 as here h by 2. I mean h by 2. Because h is here, this h is written with this one, and this 2 can be written with h by 2. Okay. So this 2 we have taken here. Okay. Why? Because you know that this is the formula sine theta upon theta, theta tending to 0, limit theta tending to 0, sine of theta upon theta is equal to 1. That's why. So this will become minus, limit will be splitted now. It can be written with both the trigonometrical ratios with sine 2x plus h by 2 and limit. Now h tending to 0, therefore h by 2 will also tending to 0. And sine h by 2 divided by h by 2. So this whole will becomes 1 and only minus limit of h tending to 0 sine 2x plus h by 2 is left. So 2x plus h by 2 is left. Now just put the value of h 0. So sine 2x upon 2, sine minus is there, minus sine 2x upon 2, 2x upon 2, h is 0. So therefore we get minus sine x. So that's why differential of, so we got the formula. This is the formula. I told you, you have to remember these formulas. We are proving actually by first principle these formulas. Okay. So this is your formula also. You have to remember d by dx of cos x is equal to minus sin x. D by dx of cos x equal to minus sin x. And sin x we have already seen. Sin x is cos x. Yesterday we have seen d by dx of sin x is equal to cos x. So by the first principle, we can do it for tan x also. Just uh, tan x. Find the derivative of, find the derivative of, find the find the derivative of, find the derivative of tan x, tan x by first principle. So again the same thing, by dx of tan x, you have to find d by dx of tan x. will be equal to limit h tending to 0 tan x plus h tan x plus h minus tan x. Tan x plus h minus tan x divided by h. Up now there is no formula for tan c minus tan d. It is for sine. So what we have to do, we can convert into sine upon cos. So limit LT we can use for limit LT limit h tending to 0, limit h tending to 0, sine upon cos. We convert to sine upon cos, sine x plus h, sine x plus h divided by cos x plus h minus tan x can be written as sin x upon cos x, and this is divided by h. Now taking LCM, so the limit will become limit h tending to 0. This LCM will become cos x plus h, cos x plus h into cos x, and h is in the denominator, so h will be written with this only. We can multiply now sin x plus h. This cos will multiply with sin x plus h on taking LCM. Sin x plus h into cos x minus cos x plus h into sin x. What we have done here, this is, we are taking the LCM. This cos will multiply with sin, and this cos will multiply with this sin. Okay. Now we have to use the formula sin A cos B minus cos A sin B. What is sin A cos B minus cos A sin B? So sin A cos B minus cos A sin B equal to sin A minus B is equal to sin A minus B. So this will become h tending to 0, sin numerator will become sin A plus A minus B. So A minus B, A is what, x plus h, and B is x plus h minus x, divided by h into cos x plus h to cos x. Okay, now this minus and plus x will cancel. Again, we have sin h in the numerator, sin h, and this denominator one h can be written as with sin h upon h, and the other term will be 1 upon cos x plus h, cos x plus h into cos x. Okay, and limit h tending to 0. Here no need to change the limit, already sin is it with h, so h tending to 0, and here also limit h tending to 0. And this whole term, you know that this value will be equal to, this will become 1. So only we left with this value And here we can put the value of cos h as 0. So cos x plus 0 means cos x plus, oh sorry, into cos x. So cos x into cos x, 1 by cos square x. And 1 by cos square x is equal to sec square x. So therefore, we got the third formula, d by dx of tan x is equal to sec square x. So like this, similarly, we can find all the formulas for cot x also, for other values also. So any trigonometrical ratio, we can find the formula by using the first principle. So tan x, remember tan x is equal to sec square x. Now we have to remember some formulas, and in the next class we will do differentiation by direct method. Direct method to find the derivative. The question is coming, find the derivative only. So we have to remember some formulas I told you, and many things we have to study. So in the starting, we should remember some formulas. These are the formulas that we have to remember for the second class. So numbering you can give for number 1, d by dx of x raised to power n is equal to nx n minus 1. Nx n minus 1. Second formula, if constant with the function is there, if there is only constant, if any constant is without variable constant, so its derivative is always equal to 0. But if it is with some function, if the constant d by dx is coming with some constant is with some function, any function, it can be any function of x, then constant can be taken out and we have to differentiate the function d by dx of x. Okay. Then we have seen sin x, d by dx of sin x is equal to d by dx of sin x is equal to cos x. We have proved also. Then this also we have proved d by dx of cos x is equal to d by dx of cos x is equal to minus sin x. This you should remember. Then next is d by dx of tan x that we did just now. D by dx of tan x equal to c square x. Then just you take the screenshot of this one. The next class we will use this formula. D by dx of cos c x is equal to minus cos sec x cot x, minus cos sec x cot x. So sec x d by dx of sec x will be sec x tan x. D by dx of sec x will be equal to sec x tan x. Then cot x d by dx of cot x. So tan x is sec square x. So cot x will be minus cos sec square x. And if there is some constant raised to power x dy dx if the function is a to the power x. Less than a minute is left. A to the power x into log of a to the base. So I will send you on your WhatsApp these formulas. You can remember these formulas. If x to the base a, x to the base a and x to the base e, there are two logs which has base a and which has base e. So if x to the base a is there, so this will be x to the 1 by x log a to the base e. And if the